Okay, so I wanted to go over a short algebra review. So, first of all, let's go over the point slope form, right? And all of the forms that you need to know on this quiz. So, the main one you need to know is this, right? Y minus y1 is equal to m times x minus x1, right? And as Mr. Takeuchi said, if you look at the, I'll do it here. If you look at the slope formula, right? Normally it's written like this: x2 minus x1 times y2 minus y1, right? And the thing is, we don't know what y and x are as we want the equation, right? And so we can just forget that we have a second point, and now, right, if you multiply both sides by y minus y1, right, we would get our um, our slope intercept form. And that's one way you could memorize it or remember it, right? But yeah, you do need to know that. Now, slope intercept form, right? Slope intercept form, this is the y is equal to mx plus b. Everyone should know this one, right? And then standard form, right? So just think of, you put all of the x's and all of the y's on one side and you put all of the constants on the other, right? And that's why we have these constants a and b is equal to c, right? And c is just some constant, right? Whereas a and b, they are both integers, right? Which is just uh, whole numbers, but could be negative, you know? So I'm just going to do a few of these problems here. So when you get 2 points like this, the first thing you want to do is find the slope, right? So slope question mark. And we know that the slope formula, right, is equal to, I'm going to do this point first, as it's going to be bigger, right? So 8, which is the y coordinate, minus 4, which is the y coordinate of the other one, right, over the x coordinates 5 minus 3. The top would become 4, and the bottom would become 2. And so we know that our slope is 2. Now, since we have a point, right, I'm going to go ahead and use this point. We have all we need to make an equation, and that shows the power of point slope form. So y minus y1, and I'm just going to use 4 as my y1, so 4 is equal to m, which is 2, times x minus x1, which is 3. And boom, you have our point slope form, right? To convert this to uh, put this into intercept form, uh, to y-intercept form, yeah, slope-intercept form, we just need to add 4 on both sides, and then distribute this, right? Okay, and so we get y is equal to 2 times x is 2x, 2 times negative 3 is negative 6, and then we plus 4 at the end, plus 4, and then y is equal to 2x minus 2, right? And that would be our intercept form. To create it to standard, right, we just need to move the y and axis to the one side, right, and then move the 2 to the other side. So we can minus a y on both sides, and then we can plus a 2 on both sides. So on the right side we will get 2x minus y, and on the right side we will get 2, but we can rearrange this as 2x minus y is equal to 2, and we got it, right? And then from here, I'm just gonna go on autopilot. You guys know how to change the uh, how to change the intercept from slope, point slope to intercept form, right? It only might get hairy when the slope is a fraction. So here, right, let's first calculate our slope. So let's do our slope is equal to, I'm going to use this as our first and this as our second. So 3 minus 5 over 8 minus 4. Right, on the top we get negative 2, and on the bottom we get 4, which simplifies to negative 1/2. Now we can use our point, right? Let's do y minus, let's use our second point. So y minus our y, which is 5, is equal to our slope, which is negative 1/2, times x minus r of x, which is 4. So, right, now this is our point slope, right? Now to convert it to uh, uh, if we want to just go to point slope all the way to standard form, right? What I'm going to do here is, if we look at our equation, what if I multiply both sides of the equation, right, by negative 2, okay? Negative 2. And the reason why I'm doing that is because if we look at this fraction, this and this will cancel out, right? And then on the right side, we would just get x minus 4. On the left side, we will get, if we distribute, right, we would get negative 2y plus 10. And then if we just put it all to one side, well, if we put all of the x and y's to the right side, we get x plus 2y, right? Because we're adding. And then if we add 4 to both sides, we will get 14 on the left side. Switch it around, then boom, we got a standard form, right? So when you have a fraction like that, multiply by the common denominator, by the common denominator, right? Lowest common multiple, and then you can immediately get to integers, right? Whole numbers. I'm gonna skip this because I don't think you guys need it. So now we get back to factoring, right? And this might be hard for some people, but I'll show you guys 3 techniques. And the first technique will be the book method of AC methods. You might have heard this before, or you might have not. But AC method, it's where you multiply the A value by the C value, and of course, this will be A, this will be B, and this will be C. And any quadratic will be in this form, okay? And so you want your A value to be in front of your x squared, your B value to be in front of your x, and C value to be on its own, right? And so A times C, right? A times C, you would get negative 15, right? Now, what I recommend you guys to do is actually not to multiply it out, right? Just leave it as 3 times negative 5, okay? And now, this number, of course, you can make it negative 15, but now, okay, we think of 2 numbers that multiply, right? That will multiply together to get this number at the end, right? And add up to negative 2, right? Add up to negative 2. And that's actually so easy because we didn't multiply it out, right? It is 3 and negative 5. Now, this is the traditional way of doing it, and the book says to split our negative 2p into the 2 numbers that we chose. So we can rewrite this as 3p squared plus 3p, right? And then minus 5p minus 5. Now we can just factor by grouping. So on the left 2 terms, we can factor out a 3p, and we get p plus 1. And then on the right side, we can factor out a negative 5, and then we get p plus 1 again. Combine like terms, right? P plus 1 times 3p minus 5. And that's one way to do it, okay? And this is the most traditional way of doing it. And this is the way you'll find in all math textbooks, but I'm going to show you two other ways. The second way is the box method, okay? Now, the box method is you literally just put tic-tac-toe, okay? And you think of two numbers that you can multiply together to get 5n, right? And obviously here, there's only and by the way, there will be an n in each here, but yeah, there's only two ways to make 5n, right? You can either do 5n times n, right? Or you could do n times 5n. And so there's not really any choice, but let's first say if our a value was 6, right? It would be 6x squared, right? There's a few ways, right? You can do 3x times 2x, or you can do 6x times x. And really, it just becomes a guessing game, right? So, for example, if I made this like if this was 12 and 1, what you do is you multiply the diagonals, right? This would become 60n, and this would become n. And if you add them up, the middle column up, this would have to go to here, right? But it's kind of hard to think about it like this, but once you get a feel for numbers, you'll understand that, right? What if this was a 3 and this was a 4, right? This would become 15 and this would become 15n and this would become 4n, and then boom, right? This does add up to this. And so how do we get our factors now? Right? You just look at the diagonals here and here, right? This becomes the first part of our answer. So 5n plus 4, okay? And then here and here, the second part of our answer is n plus 3, right? Now, the last way, I'm going to do it on this problem, is a variation uh, of the AC method. And this way is the way that I do it, okay? Now, you still multiply your A value by your C value, right? 5 times 9. And then you do the same thing. You think of two numbers that, right, this would become 45. You think of two numbers that multiply to 45, but add to negative 18, right? And so, if you look at the factors, right, what, you know that this is 5 times 9, right? But we can look at 9 as 5 times 3 times 3, right? And what if we combined this and this, right? This would become 15 times 3. What are we trying to get to? We're trying to get to negative 18, right? I'll leave that on the side. Negative 18, right? And so, if we add a negative to both factors, right? A negative to both factors, we know that that will add up to negative 18. So boom, we have our factors. But this is really the catch of my method. So what we do is we actually just put this in, we actually just write these two things like how we would if our a value was equal to 1, right? So if I gave you the equation x squared minus 18x plus 45, you would factor this as x minus 15 times x minus 3, right? Because you thought of two numbers that multiply by this and add up to here, right? But we first write this, right? But what we do is we look at our a value, right? Our a value is 5, and we put it under each of our values here. Sorry, our a value is 5. 5, right? Now, for here, you know that this cleanly divides. So, this becomes, right? This becomes x minus 3, right? Now, because this does not cleanly divide, right? What we're gonna do is we're gonna put it in front of our x, okay? So this becomes 5x minus 3, okay? And boom, you have your factors, and it does work. Let's say, for example, if we had the factors x minus 2, sorry, x minus 6 times x minus 3, right? No, 5 and 3, right? And our a was actually 15, then we would still divide everything by 15, and then we would simplify, okay? This would become 1 over 3, and this would become 1 over 5, okay? And then now that we still have a denominator, we would put it in front of our x's, and then we would get our factorization again, right? So just divide however much you can, but if there's still a fraction that you can't simplify, then just put that number in front of the x. And you might be confused as to why this works, and honestly, it has to do with uh, all of our numbers being whole numbers. But yeah, this is the third way, and this is the most fun way, because what the sneaky thing that you can actually do is you don't even have to write the second number. You can just do x minus 15 over 5. You know that this would become x minus 3, right? And then you look at what you needed to get to, right? Our quadratic. And then you think of, right? If you were to multiply, uh, if you were if you were to multiply another factor, right? It looks something like, and then there's two numbers, right? And to get to 5x squared, you know that you have to multiply this number by another number, right? And so you know that this has to be 5, and then negative 3 times what number equals 9. And so you know it has to be negative 3. And then we can turn that into a negative, right? And 3. And boom, you don't even have to divide by anything. You can just reconstruct it. So yeah, that was kind of lengthy. I'm not going to go over any of the graphing of the absolute value. Although there's one point that I want to work out. If you have an equation like this, right? 3 minus x plus 7. This is the same thing as if you switched around this, right? Because this is a property of absolute value, right? Absolute value of negative x is equal to x, right? And you know that x is also equal to the absolute value of x. And so if we jump from here to here, then that's how we achieve this. And that might make solving easier for some of you, right? Also know that this value will always be the value of your vertex, the y value of your vertex, unless there's another value close that's not adding or subtracting to y. Okay, I think that's it. Okay, bye.